Hello and welcome to the Solubility Lab for Gen Chem. So for this lab, we're going to be using a lot of different materials, as you can see here, including filter and filter paper. The HCl, 1.01 molar, that's going to be our titrant. Calcium hydroxide, that is going to be what we titrate into and what we're trying to find out the KSP of, along with our indicator, which will allow us to figure out when we have reached the neutralization point for our titration. All right, so to start off, we're first going to want to saturate calcium hydroxide by adding it into water. Now, saturation means that we've added so much of the solute, which in our case is calcium hydroxide, into the solution or the solvent, which is water, such that no more of the calcium hydroxide can dissolve. We know we've reached the saturation point when we notice that solid calcium hydroxide starts to form at the bottom of our beaker here. That means that every little piece of calcium hydroxide solid we put in will force some more calcium hydroxide to fall out of the solution, i.e. become its precipitate. So once we mix it in and we let it settle for a bit, if we start to see some solid calcium hydroxide form and a liquid or an aqueous layer form on top of that, that's how we know we've reached the saturation point. We've added a little bit more calcium hydroxide here. You can see the solution is still fairly opaque. But if we go down to eye level, we should start to see a separation of the aqueous components, the aqueous calcium and aqueous hydroxide ions, on top of our solid calcium hydroxide. So once we know that we've reached that saturation point, we could see that solids start to form at the bottom. We're going to go ahead and filter out the solid portion, so we only have the aqueous calcium and hydroxide ions. We're going to use a filter paper to do that, and a filter. So first we want to wet that filter paper and place it into our filter funnel, as you see here. So that filter funnel allows us to filter out any solid parts or solid particles from our aqueous solution. You can see here, it's got a bunch of holes to help filter the aqueous solution through. We're going to place this filter funnel on top of an Erlenmeyer flask attached to a vacuum tube. So this is what we call vacuum filtration. We're going to use the vacuum from the vacuum tube. We can turn it on right there. And that's going to force air through the top of that filter paper down into that Erlenmeyer flask. And you can see that that forces the aqueous solution to be pulled straight through. We can watch it very quickly go through here. Normally, this would take several hours, but by using vacuum filtration, we can use this or do this process in a few seconds instead. So the force of the air from the vacuum helps us push that through. And we can add the rest of our calcium hydroxide solution, as you see here, pouring it on top of our filter paper. And we want to make sure not to get any solid into that filter. If possible, I want to leave all the solid behind. Now we'll turn on the vacuum once again, and that will pull all of the liquid or the aqueous calcium hydroxide ions back through the filter paper, back through the filter, as you see here. There we go. We've got most of it through. So this ensures that our solid calcium hydroxide is left behind, and we're only dealing with the aqueous ions of calcium 2+ and OH- or hydroxide minus in our filtrate, which is at the bottom of this Erlenmeyer flask. Okay, looks like we've used up all of that filter. So we'll go ahead and remove it. You might notice that there's some of the solid layered onto that filter paper. That's why we use it. Now we can take that aqueous solution and put it into an Erlenmeyer flask that has a cap on it. Now this is important because as soon as we get that aqueous solution, the carbon dioxide in the atmosphere is going to want to react with the OH minus and this calcium plus to produce carbonic acid. Now we don't want that to happen. So as soon as we're done, we're going to go ahead and place it into this Erlenmeyer flask and seal it, cap it. That way the extra carbon dioxide in the atmosphere cannot react with it. Next, we're going to go ahead and prepare our burette for our titration. So we're going to pour 0.01 molar HCl, hydrochloric acid, into our burette. That's going to be our titrant. And we're going to titrate that into our calcium hydroxide solution. So the H plus from the HCl will neutralize the OH minus from the calcium hydroxide. So we'll go ahead and set up our burette. So we want to start by recording our initial volume of our burette here. You can see it there. So go ahead and write that down. And now we're going to prep or prepare the calcium hydroxide solution for when we titrate our HCl into it. So I'm going to add 50 milliliters of water. That's going to help increase the total volume of this solution. To that, we're going to add about 10 milliliters of our saturated and then filtered calcium hydroxide solution. So we'll take 10 milliliters using our volumetric pipette. We'll go ahead and place that into the 50 milliliters of water that we already have. Then we'll go ahead and add our indicator, which is thymol blue. So this will be blue at basic pH, and then it will turn into a yellowish orangish color at acidic pH. So we'll add just about 4 or 5 drops. That's all we need. We see that there's a nice little blue tint to this solution. That means that what's inside is a basic solution, which makes sense because there's calcium hydroxide, which is a base. So we'll go ahead and put it in front of a white background to help us see it a little bit clearer. All right, so now we will go ahead and start putting the titrant HCl into our calcium hydroxide, drop by drop. So we're going to start the titration. And once it reaches the equivalence point, which is of course when the moles of acid equal the moles of base, or the moles of HCl equal the moles of hydroxide, not calcium hydroxide, but hydroxide, then the solution will change color. So it should change into a nice little yellowish orangish color. For now, before that point, it's going to stay the same color. So we're going to drop drip by drip the HCl into it, swirling every once in a while to make sure that our solution is homogeneous. All right, so right there, we have hit the equivalence point. You can tell because the solution has changed color from blue to a nice little orange or yellowish hue. So now we'll record our final volume, as you see here, and that will let us figure out the volume delivered. If you subtract our final from our initial volume, we'll know how much HCl it took to titrate that amount of calcium hydroxide. So go ahead and record that. And we'll do that 2 more times. So for our second trial, we'll go ahead and re-top off our burette with hydrochloric acid. So our initial volume there. And now we will go ahead and prepare our calcium hydroxide by putting in water and taking 10 milliliters of our filtered calcium hydroxide solution, put it into our 50 milliliters of water, and then add some more drops of our thymol blue indicator. And we'll go ahead and start our titration again. And of course, we're going to be swirling during our titration just to make sure that the solution stays homogeneous. All right, there we go. We've hit the equivalence point. You can tell because it changed color. We can go ahead and record our final volume there. And we'll do it one more time to get 3 total trials. So fill it with 50 milliliters of water. Add 10 milliliters of our calcium hydroxide solution. And then add a few drops of our thymol blue indicator. We'll go ahead and homogenize the solution and then start our titration again. So our initial volume is right there. All right, and there's our final. So you see the color has changed. You can go ahead and record the final volume. And there we go. Thanks for watching.